This video is about the Fibonacci sequence. Using other tools, it is possible to calculate the Fibonacci numbers without using the non-recurrence method. I developed a method which makes that possible. As you can see in the image, one can calculate the Fibonacci numbers using a recurrence relation. We assume that f0 equals 0 and f1 equals 1. For numbers bigger than 2, one uses fn equals fn minus 1 plus fn minus 2. The first Fibonacci numbers are 0, 1, 1 again, 2, 3, 5, 8, 13, 21, and so on. So let's take a look at this new method. First, we must take the golden ratio and use it to calculate the Fibonacci numbers. The golden ratio is equal to 1.618033988,749, and it goes on to infinity without a repeating pattern. Let's take a look at the graph. There are 4 columns. As you may have noticed, the first Fibonacci number is 1 and not 0, so the sequence for the algorithm begins in 1. For the first 9 elements, from 1 to 34, the equation 1.6 to the power of m over 2 is used. You may have noticed that the column k is always rounded to the units, so the equation uses the function round to calculate the Fibonacci numbers. The m value corresponds to the value of the position used for the algorithm. One only uses one decimal place for the values for the golden ratio. The value 1.6 stands for this value. For the values from 55 to 2584, the equation used is 1.61803 to the power of m times 34. That is, times the previous Fibonacci number. One can also use 1.61803 to the power of m divided by 2 and multiplied by the sum of the previous 3 numbers, that is 68, which is equal to 34 plus 21 plus 13. The first number of this sequence uses the value m, which corresponds to 1. The value of m for this sequence begins in 1 and goes up to 9. For the third sequence, one uses 1.61803398887 to the power of m multiplied by 2584. This sequence encompasses the values between the position 19 and 36. The equation uses the values of the position between 1 and 18. So for 4148, the position 1 is used, whereas for the value 149303552, the position 18 is used. For the last sequence, one used the equation 1.6180339887499 to the power of m multiplied by 149303552, of course all rounded up. The sequence begins in 2415717 and goes up to 6557470319843. The positions used range from 1 to 27. The same method is used for the last sequence. A problem occurred at the end. I think it has to do with the decimal places limit on the spreadsheet I used. Anyway, one can begin another sequence using the same method and more decimal places in the golden ratio. The values differ 1 unit from the calculated. I think this doesn't pose any problem. If the decimal places are correct, it could mean that the sequence may grow even larger than expected.